Hello, we are teammate, and our group project is about handwriting financial calculator based on the image recognition technology. And this is the contents of our today's presentation. Next stage, please. Okay. And so let's go through the introduction part first. Next page, please. Yeah. Documents and applications are increasingly becoming digitalized, while handwriting mathematical expression recognition is still a most challenging job to do in the area of computer vision. Meanwhile, the CNN algorithm can be regarded as a good method in the field of image classification. Our group would like to apply CNN to complete image recognition tasks so that create a handwriting financial calculator. Next. Okay, next, let's have an analysis of our targeting problem. The first part is the difference between the normal scientific calculator and a financial calculator. The normal scientific calculator is equipped with elementary function calculation, statistics analytics, regression analysis, and some other functions, which are commonly used in general numerical function calculation in science and engineering or practical engineering field, where the financial calculator is developed for the financial industries. So, please turn to next slide. So in comparison to the physical calculators, either scientific or financial one, what is the advantage of handwriting calculator? The answer can be described from 4 parts. Firstly, lower financial burden. Traditional physical calculators are expensive, while virtual calculator is free or will charge very little. Secondly, easy to master. Traditional financial calculators are complicated to use, may require certain training. However, users can operate according to the instructions due to the handwriting one's interactive interface. Well, next is the rich application scenarios. The handwriting product can be easily used on mobile phones, iPad, etc. We're not in need of bulky computers or specially carried financial calculators. In addition, the handwriting calculators have very fancy interface, which make them more attractive. Last but not least, let's go through our targeting customers. We are sure that amateurs having strong interest in finance will be really into our product, for we provide the business functions of various financial calculators, which can help users to understand the full picture of finance faster. Freshmen majoring in finance or business will be definitely interested in our product too. What's more, we also design our product for some professionals, such as wealth managers, real estate sales, stockbrokers, and so on. We believe our excellent UI interface makes them look more professionals and helps their career development. So I will pass on to my teammates to talk more about our project.
Hello. I will talk about the formula recognition part. Recognize the name of formula is the first step of our intellectual program. So the accuracy of this model is of great importance. For recognizing the name of formula successfully, our team uses techniques below. First, we need to collect enough train set. Why not recognize each letter? The first reason is that cursive handwriting could not always be extracted successfully. And the second reason is that even if extracted successfully, because of cursive handwriting, the deformation of each letter is serious, which affects the accuracy of recognizing each single letter. And then we will build our CNN model. Next page, please. For collecting train set, considering the number of formulas is limited, our team then decided to create our own data set. There are several websites that could help us to generate handwriting fonts. We finally chose Font Meme as it contains various font styles. For each name of formula, our team generates 100 samples by different font styles. As our team needs to recognize 10 words, we prepare 1,000 samples for train set. The total number of train set is not large, but since the PCE of each word is significantly different, the accuracy of the model would be acceptable. And here is a screenshot of the sample of auto-generated handwriting NPV. And next page, please. And next, we will build our CNN model. To prepare PNG format train set for CNN model, we need to first convert them to Pico format, so feature and label could be easily paired for later training. At this step, we will also standardize the size of images to be 50, which could be useful for later feed these images to our model. After converting format to Pico format, we could start to train our CNN model. As our dataset is not large, we don't need to worry too much about computational resources usage. We could decrease the learning rate so that the model could fit train set better. And our team finally set learning rate to be 0.0001 and the batch size and epochs to be 16. And the configuration table is shown here, and the training process is here. And the CNN could fit our train set accurately. The final accuracy is about 95%. For next step, we will transfer the name of formula to our terminal. Our terminal would implement different formulas based on the result recognized at this part. And my teammate Yiling will talk more about this.
Thanks for Haoxiang. Now let me introduce the following part. Decimal handwriting recognition. We segment this process into 3 steps, including positioning, segmentation, and saving of handwriting numbers, recognition of decimal points, and model architecture training and evaluation. Next page, please. For the first time, positioning, segmentation, and saving of handwriting numbers. The problem we want to solve is to make the segmented numbers to be in order in the output. So we store the 4-point coordinates of the above rectangle in a list, and then arrange them in order according to the size of the x-axis coordinate location, so that the stored coordinates are the actual order of handwritten numbers. Then the image is sliced according to the coordinates of the 4 points of rectangle, so that we get the desired number. The segmentation effect figure is shown in the left side. Next page, please. For the second step, recognition of decimal points, we use empirical method to identify the decimal point because the circumscribed contour area of the decimal point is much smaller than that of other numbers. Therefore, we judge that if 4 times of the minimum area smaller than the maximum area, the segmented image must be a decimal point. So we successfully identify the decimal point, and the identify effect figures are shown in the left side. Next page, please. For the third step, model architecture training and evaluation, we use the classic MNIST dataset and split the data into 60,000 train sets and 10,000 test sets. Then we built the Lanet style model to train and feed the model. We set the approach equals to 5, and we get the test set accuracy at 95.16%. Then let my teammate Yunfan to introduce the following parts.
Okay, thank you, Yiling, and I will then introduce our solution. Our product integrates the coordinate technology of machine learning and finance, and uses handwriting recognition to help users solve the calculation problems encountered in the process of studying finance. Users just need to write down the formula, write down the parameter, and then can get the results. Our product provides with 4 different versions. Our free versions provide with some basic formula, and there is a limit to the number of uses per user per day. Our professional version provides with all professional formula and unlimited numbers of uses a day. And it also has programming function, which means users can design and deploy with their own formula. Our enterprise version has all the functions that professional versions has. Besides, enterprise version has 2 more functions, such as unified deployment control, which means administrators can design a function that distributes to all the users in a company. Our special versions perform as API, which means other educational productions can incorporate our product as a plugin. For example, a Microsoft Word application can have a special version. With such plugin, users can just type the financial formula easily in the Word. Our product mainly use CNN algorithm as well as Keras, PyTorch, and Grp8. With respect to the technical details, our UI will first load the model results, then we define a prediction function and bind it to the prediction bottom. Finally, we define various formula and use the tokenized digits to compute. Now I will give you a live demo. Okay, for example, I want to compute that the annual interest is 5%, and I will deposit $100 at the beginning of the year, and then I will deposit $100 every month. And I want to know how much can I get after 10 years. So I want to calculate future value. Then I just write down F3. Okay, check now, and it can recognize that I want to calculate future value. Then I click go to the calculator, and come this, I write down the parameter. Okay, just click calculate now, then we can get the results. Okay, then my teammate Ziyu will talk more about that.
Okay, thanks, Yunfan. So in conclusion, we demonstrate the application of deep learning in image recognition and finance, and innovate handwritten financial calculator, a new financial tool of great market value. And we achieve a high image recognition accuracy, above 98% for English characters recognition, and above 95% for decimals recognition. And this financial calculator supports calculation of various financial variables. And because it can calculate based on handwritten variables and parameters, it can help people conduct financial calculations more efficiently. So we believe our product is of great market value. Next page, please. As for future study, first, we can add more complex financial variables and try to expand to some other fields, such as the calculation of handwritten variables in the fields of mathematics and physics. And another point is that currently we can only recognize handwritten numbers, decimal points, percent signs, and some simple mathematical operators. So in the future, we think we can add some more complex mathematical symbols and expression recognition functions, such as radical signs, logarithmic symbols, powers, and so on, to achieve calculation of more complex variables. So all in all, our project focuses on how deep learning algorithms are used in image recognition and in finance. Okay, thanks for listening.